Here is another video on how you can use formula questions to expand your assessment base. So I created a question here. This is an average atomic mass or an isotope abundance question. And if you watched the other videos, you're familiar with how those variables can be set up. This one says determine the approximate average atomic mass of the theoretical isotope humanium, given that the isotope abundances are a certain percent of the X isotope, a certain percent of the Y isotope, and a certain percent of the Z isotope. So down here, we see that A is going to be a percentage. So we can give that a percent value of between 15 and let's say 25. It's important to watch your percentages. You don't want the sum to be over 100. For B, that might be between 26 and let's say 45%. And if you were to add up the maximum values, 25 and 45, that would give us 70%. And then that means the remaining 30 would go to the Z isotope. X is a mass number for the X isotope of humanium, which means we can give it some number, let's say 135 to 138. So that could be 135, 136, 137, or 138. Then we can have the B or the Y isotope. That might be 139 to 141. We're giving it a more narrow range. And then we have the Z isotope, which would be 142. Let's say it's 142 or 1 up to 145, 144. So we don't have any overlap between our isotopes, and that's good. We also want these to be whole numbers. You can have your percentages be decimal numbers, but we of course want our mass numbers to be whole. And if you scroll down, you have to put the formulas in. So in this case, you have to be very careful. A and B are percentages. So I'm going to use the intermediate formula trick here. I'm going to say that the isotope 1, just some intermediate variable I'm making up, that is going to be equal to, and we want to turn whatever the number is, let's say it is 17, so it's in our 15 to 25 range. If it is 17, we want to turn whatever that number is into a decimal. So that means that we're going to take the value of A, divide that by 100, and we're going to multiply that by the mass, which would be X. So that gives us the relative abundance for the portion of the isotope X. You could also call that iso X or whatever you want. So I'm going to save that. I need some more digits here. I'm going to do the same thing. So iso 2, that's going to be B. So B is a percentage as well. Divide that by 100, turn it into a decimal. Multiply that decimal by Y, which is the respective mass that correlates to B. Save that. And then we're going to do the last thing with this one, iso 3. That's going to be, now in this case, since it does say the remainder, it would have to be 100 minus A minus B, but we want to turn that into a decimal as well. So we can close that, divide by 100, and then multiply that by the mass of Z. Now these are all the piece components. We need to add those all up. So iso 1 plus iso 2 plus iso 3, and that's going to give the final answer. So the 140.82 is the approximate average atomic mass of this isotope. And you can recompute, and you'll see that you get all sorts of answers here. You'll probably want a tighter range on something like this, so maybe a 1% error after you generate perhaps 30 different combinations. So we are going to generate those and then update our question. Click Save, and then Preview to see what it looks like. And it looks like a good solid isotope abundance problem where you're given a percent, you're given two percentages, there's a third remaining percentage, and we have it coded in just right. And that's yet another way you can use formula questions.